Hey guys, welcome back to my YouTube channel. From the previous video, I've discussed about conic sections parabola whose vertex is at the origin. And for today's video, I'm going to discuss about parabola whose vertex is at edge K. Our objectives for this discussion is to identify the properties of parabola whose vertex is at the edge K and write the equation of parabola with vertex at edge K. Parabola is the set of all points in a plane equidistant from a fixed point focus and a fixed line directrix. The first equation is the quantity of y minus k raised to the power of 2 equals 4a times x minus h. An example for this equation is the quantity of y minus 1 raised to the power of 2 equals 4a times x minus 2, and this is its graph. For its properties, the vertex of this equation in the right side is 2, 1. The focus is at a plus h, k. Our value of a for this equation equals 1, so the focus is at 3, 1. The directrix is the line x equals negative a plus h. Just substitute the value of the a and h, so the directrix x equals 1. The axis of symmetry is the line y equals k. So our axis of symmetry is y equals 1. And for the opening, as you can see in the graph, it opened to the right. Our second equation is the quantity of y minus k raised to the power of 2 equals negative 4a times x minus h. An example of this equation is the quantity of y minus 1 raised to the power of 2 equals negative 4a times x minus 2. And this is the graph of this equation below. Its properties are the following. The vertex of this equation is 2, 1. The focus is at h minus a, k. Again, the value of our a is equals 1, so our focus of this equation is 1, 1. The directrix is the line x equals a plus h, so x equals 3. The axis of symmetry is the line y equals k, so our axis of symmetry in this equation is y equals 1. And for the opening of the graph, it opened to the left. The third equation is the quantity of x minus h raised to the power of 2 equals 4a times y minus k. An example for this equation is the equation below. The quantity of x minus 1 raised to the power of 2 equals 4a times y minus 2, and this is its equation. The properties are the following. The vertex of the equation below is 1, 2. The focus is h, a plus k, and the value of a for this equation is 1, so the focus is 1, 3. The directrix is the line y equals negative a plus k, so y equals 1. The axis of symmetry is the line x equals h, so x equals 1. And as you can see in the graph, the opening opens upward. Lastly, the fourth equation is the quantity of x minus h raised to the power of 2 equals negative 4a times y minus k. For example, in this equation is the quantity of x minus 1 raised to the power of 2 equals negative 4a times y minus 2. And in the right side is its graph. So the properties are the following for this equation. The vertex is 1, 2. The focus is at h, negative a plus k. The value of a is 1, so the focus for this equation is 1, 1. The directrix is the line y equals a plus k, so y equals 3. The axis of symmetry is the line x equals h, so the axis of symmetry is x equals 1. And lastly, the opening of this graph opens downward. Let's have an example. Number 1. Find the equation of the parabola with vertex at 3, -2 and focus at 3, -4 and sketch the graph. So let's first plot the vertex and the focus. So we have this graph if we plot the vertex and the focus. So as you can see, the vertex is above the focus and the distance between the vertex and focus is 2. So it means that we can visualize it that the graph is open downward. So let's use the equation, the quantity of x minus h raised to the power of 2 equals -4a times y minus k, since the graph opens downward. Next, substitute the value of h, a, and k in the equation and solve the rest. So the equation of the parabola is x squared minus 6x plus 8y plus 25 equals 0. And if we graph this equation, we have this graph. Example number 2. Given the parabola, the quantity of y plus 2 raised to the power of 2 equals -8 times x minus 3, find the vertex, directrix, ends of latus rectum, and sketch the graph. So first, the vertex of this equation is 3, -2. Next, let's find the value of a. So -4a equals -8, a equals 2. Next is the focus. The ordered pair to find the focus is h minus a, k. So our focus is 1, -2. Next is the directrix. X equals h plus a equals 3 plus 2, so x equals 5. Next is the end of latus rectum. We have the ordered pairs h minus a, k plus 2a, and h minus a, k minus 2a. Just substitute the value of h, a, and k and solve the rest. So the end of latus rectum for this equation is 1, 2, and 1, -6. And this is the graph of the equation. Exercise A. Find the equations of the parabola and equation of the directrix based on the given. And exercise B. Given the equation of the parabola, fill in the blanks. If you have any questions, clarification, and suggestions, kindly comment it down below.